Today, we are diving into one of the most important and honestly one of the coolest innovations in AI that you've probably never even heard of. And no, it's not some flashy new language model. It's actually a framework that makes all those other models way smarter, way more reliable, and, genuinely useful. It's called Retrieval-Augmented Generation, or for short, RAG.
But before we get into the weeds, let me ask you a quick question. In our solar system, what planet has the most moons? Go on, think about it for a second. You've probably got an answer locked in your head, right? And you're probably feeling pretty sure about it. Well, that's exactly how a standard large language model feels.
If you said Jupiter, well, you would have been right a couple of years ago. But science, it doesn't stand still. As of today, the right answer is actually Saturn, with a whopping 146 confirmed moons. And this little bit of trivia, it perfectly highlights the massive problem we're talking about today. Knowledge isn't static. The facts are always changing. And that leads us right to the fundamental flaw of almost every large language model out there. See, they're trained on a fixed snapshot of the internet. It's like they're sealed in a time capsule from the past, with absolutely no connection to what's happening in the real world, right now. So let's break down these challenges, because they really stack up. First, you've got that outdated information, just like our moons example. Then there's the fact that it can't access any of your private internal data. Think of all your company's documents. Because of that, it has no way to verify its sources. And all of this leads to the big one, the one you've probably heard of, hallucinations. That's when the AI just confidently makes stuff up.
So, how in the world do we fix this mess? Well, the solution is this incredibly elegant and actually a pretty simple idea called RAG. The best way to think about it is this. We're basically just giving the AI a library card. We're letting it access a library of fresh, relevant information before it even tries to answer our question.
I love this analogy. Think of the LLM as a really talented journalist. It knows how to write a fantastic story. But instead of just writing from memory, it first goes to an expert librarian, that's our retrieval system. And that librarian finds the most relevant, up-to-date books, that's your data, for the journalist to use.
So, to put it a little more formally, RAG is the process of finding or retrieving external, up-to-date information and giving it to the LLM as context before it generates an answer. It's this simple process that grounds the model in reality, in the here and now.
The basic version of this breaks down into 3 super simple steps. First, you retrieve the relevant documents. Then, you augment the user's question with that new info. And finally, you tell the LLM to generate an answer based only on the facts you just gave it. Retrieve, augment, generate. Seems simple enough, right? Well, yeah, for a slick demo it is. But in the real world, it's a whole different story.
And this is where we hit the big twist in our story. That beautiful, simple 3-step process, it's actually incredibly fragile. There is a massive, massive gap between a clean little demo and a real, reliable system that can handle the messy, chaotic data and questions that happen in the real world.
In fact, researchers at Google found something kind of shocking when they dug into this. When you feed an LLM bad or irrelevant information, it doesn't just get the answer wrong. No, it gets much worse. It actually becomes more confident in its wrongness. It hallucinates even more. This finding is the key. Bad retrieval is so much worse than no retrieval at all.
So how does it break? Okay, imagine you asked your company chatbot about the parental leave policy. A simple RAG system might pull up an old policy from 2019. Or it might chop a document right in the middle of a sentence, cutting off the part that says who's eligible. Or it might find a perfectly clear table and turn it into a jumbled mess of text. In every case, the result is the same. The AI gives you a confidently wrong answer.
Okay, so if the simple version is so easy to break, how do you build a system that you can actually count on? The answer is what's called a production-ready RAG architecture. It's a whole pipeline with multiple stages, all designed for one thing, and one thing only: trust.
It all starts with how you treat your data. You can't just dump all your documents into a folder and hope for the best. A smart system first restructures them. It learns the difference between a title, a table, and a paragraph. Then it does something called structure-aware chunking, which is a fancy way of saying it splits files intelligently, so it never cuts off a table or sentence halfway. Finally, it creates rich metadata for every single chunk, things like summaries and keywords, to make finding that information later way, way smarter. And where does all this amazing data go? Well, a production system needs a modern database that can do two things at once. It has to search for conceptual meaning, the vibe of what you're asking for, but it also has to be able to filter for hard facts, like only documents from last quarter or only from the HR department. You absolutely need both to find exactly the right snippet of information.
Next up is the search itself. A truly robust system uses something called hybrid search. It combines vector search, which is amazing for finding similar ideas, with old-school keyword search, which is critical for catching exact phrases like a product name or an error code. Then it takes the results from both and uses a re-ranker to intelligently push only the absolute best, most relevant results right to the top.
Okay, but what about really complex questions? The kind that have multiple parts. For that, the system needs to actually think. This is where a reasoning engine comes in. It's like a project manager. It takes a big question like compare our sales in Europe versus Asia for last quarter, and it breaks it down into smaller steps. Then it can use different tools or even call on a team of specialized AI agents, like one for finance, one for sales data, and they all collaborate to build one comprehensive answer. It's pretty incredible.
And finally, and this might be the most important part, you need quality control. Before any answer ever gets to a user, a gatekeeper AI checks if it's even relevant. Then, an auditor AI double-checks that the answer is actually based on the sources you provided and that the LLM isn't just making things up. And before any of this even goes live, the whole system is stress-tested. Engineers are actively trying to break it to find all the weak spots before you do.
So, after all that technical detail, why does getting RAG right really, truly matter? Well, it's about what this technology becomes. It's the difference between AI being a clever but unreliable toy and it being a tool that you can actually depend on to make critical decisions.
Because at the end of the day, this whole complicated architecture, it really only serves one purpose. It's not just a technical challenge. It's how we build genuine, verifiable trust between us and our AI.
And if you think this is all science fiction, something that's years away, you have to hear this. Right now, on some of the biggest cloud platforms, over 80% of new databases aren't being set up by human engineers anymore. They're being created by autonomous AI agents. These agents are using advanced RAG systems just like this to understand a problem and build their own tools to solve it.
So that leaves us with one last thought. We started all this with a simple question about moons. But now that we have AI systems that can build, verify, and reason with their own knowledge, the real question isn't about moons anymore. It's, what are the really big questions we're going to ask next?